All right. So now we've got two graphs there, and we're going to see if we can figure out what the transformation is. So we've got f of x, the original one there in red, and they tell us that there's some vertical and horizontal compressions, and then we end up with the blue graph. So first of all, I want you to think, and they've labeled some points there so we know which points have changed. I want you to just think about it and see if you can figure out what's happened vertically. Has it been stretched or compressed? What's happened horizontally? Has it been stretched or compressed? So can you visualize that it's been squished vertically? There's been a compression vertically, and then also appears to be a compression horizontally. So if you looked at this, you probably, through guessing and checking, come up with appropriate numbers that would do that. What we're going to do is we're going to set up a system to help us find this. We're going to look at some points that have changed. I'm going to label this point on my original graph A, and it changed to this point. Sometimes when we write a change to a specific point, we add a little prime symbol after the value. So I'm going to call that A prime. And the second point that we have down here, I'm going to call B, and I'm going to call the switch that we did B prime. So what we're going to do is we're going to look at what is the vertical distance between A and B, and what is the vertical distance between A prime and B prime. And that should tell us what we need to do to compress it vertically. And we'll do the same thing horizontally. So we'll label this as just if the vertical distance from A to B. And it does matter because sometimes there's reflections. So if I go from A to B, I'm going to be going down how many? From 9 down to -8. Is that where it is? That looks like it's going down 17. You can write it as down 17 or -17. But it makes sense that my distance between A to B is 17. And then if I look at what happens with my vertical distance when I go from A to B prime, well, I'm still going to be going down. So obviously there's no reflection here. 4 and 5. Is that right? 4 and 5? 4.5, sorry. 4 and 4.5 is going down 8.5. Wow, worst squiggle bracket ever. Gotta practice those. There we go. So from A to B, you go down 17. From A prime to B prime, you're going down 8.5. What's the change there? Well, I thought it would be 9 because it looks like it's right at half, but they labeled the point at 4.5. So I thought it was 9 as well when I was just visualizing it. But because they've labeled this blue point A prime at 1.5, 4.5, it's 8.5. And the reason it's perfectly 8.5, because what's the relationship between 17 and 8.5? It's cut right in half. So what has happened to our y values? Our y values are getting multiplied by a half. That's the transformation that takes place with the y values. Then if we look at the horizontal distance, well, from A to B, that would be going back 1. So I'll write that as -1. And from A prime to B prime, we go from 1.5 to 1, so that's back a half. So what's happened to our x values? They've also been multiplied by a half. So what we did here is we were able to describe what's happening. We were able to take the points that we knew and use the differences between them, both vertical distances and horizontal distances, to be able to describe that the change is our y values got multiplied by a half and our x values got multiplied by a half. Now we can go and write the equation by saying, well, if this is what's happening, if these are the transformations that's happening, how would I write that? So my image graph, the blue one, in terms of the function f, if I have a y multiplied by 1/2, that happens outside of the function, in front, exactly the same. If I have x values multiplied by half, that happens inside the function, but instead of a half, I'm going to write 2. 2 over 1, the reciprocal. So now we have the image graph in terms of the function f. This one you might have been able to figure out just by looking at it. Later on, when we do have the questions where we have transformations like this and it's moved left, right, and up and down, it's harder just to figure it out. So this technique of doing the vertical distance and the horizontal distance and figuring out those transformations first is going to be really helpful. And we'll see that in our next section. So the questions you can do after this one are 5, 12, 13, and 14.